The lecture is about RSA algorithm. Before going into details, let me introduce electronic security. Nowadays, most of our communication is in the form of internet and other electronic communication. Therefore, the importance of electronic security is increasing. Cryptography can be used to protect email messages, credit card information, and corporate data. This can be defined as the art of protecting information by transforming it into an unreadable format, so that anybody who is observing it is unable to read. The key terms in cryptography are plain text, encryption, ciphertext, decryption, and key value. Plain text represents the information which we would like to protect, and the process used to transform plain text into unreadable format is known as encryption. After transformation into ciphertext, it is transmitted to the other user. Usually, at the sender side, encryption is performed. At the receiver side, the decryption is performed to get the plain text. For transformation and detransformation, a key value is required during encryption and decryption. The encryption systems are broadly classified as symmetric key and asymmetric key cryptographic techniques. In asymmetric key systems, we use the same key for encryption and decryption, and it must be known as both to the sender and recipient. Where in asymmetric or public key systems, two keys are used, namely public and private keys. A public key is used for encrypting the messages, and a private key is used for decrypting. Symmetric key systems are simpler and faster, but the main drawback is exchanging the key in a secure way. Symmetric key by both parties should be used. Public key encryption avoids this problem because the public key can be distributed in a non-secure way, and the private key is never transmitted. Even the public key is known, it is impossible to deduce the private key. The symmetric key cryptography is also known as secret key cryptography. Several symmetric key cryptography systems are existing, like DEA, Data Encryption Standard, and Triple DEA, International Data Encryption Algorithm, shortly known as IDEA, Blowfish, RC5, CAST 128, etc. Due to advantage of public key cryptography, many algorithms are using public key systems. This scheme mainly composes 6 ingredients like plain text, encryption algorithm, public and private key, ciphertext, decryption algorithm. The sender, having plain text, uses a public key for encryption. Then the output is called as ciphertext, which is transferred to the recipient. At the received side, it uses the compatible private key for decryption, and the output is known as the plain text. The two popular public key cryptography systems are RSA and Diffie-Hellman. RSA is named based on the inventors Rivest, Shamir, and Adelman. It is a block cipher algorithm and is most widely used algorithm. Whereas Diffie-Hellman algorithm mainly used for exchange of secret key securely between two parties, especially for symmetric encryption techniques. So here, using discrete logarithms, we compute this secret key value. The lecture is about RSA algorithm. So here, the key generation is very important. So for which we are using two large prime numbers, P and Q. Then we calculate n value, which is the product of P and Q. Then we calculate phi of n, which is P minus 1 into Q minus 1. Then we have to select an integer in such a way that GCD of phi of n and E is equal to 1, where 1 is less than E less than phi of n. Then we calculate D in such a way that E inverse mod phi of n. Then public key is calculated as KU, where E and n values are given as input values, and private key is a function of D and n values. In RSA algorithm, encryption is performed if plain text M is given, where always M is less than n. The ciphertext is produced as C is equal to M power E mod n. And at the receiver end, if ciphertext C is available, the plain text is extracted using M is equal to C power D mod n. Here we will discuss an example where we are taking two small prime numbers P is equal to 17 and Q is equal to 11. Then we calculate N value, which is a P into Q, which is equal to 187 in this example. Then we calculate phi of N, which is P minus 1 into Q minus 1. This is 160. Then we select an E value in such a way that E is relatively prime to phi of N is equal to 160 and less than phi of N. Suppose if we choose E is equal to 7, then according to the earlier formula, D is obtained as 23. Thank you.